Hello, and welcome to our virtual Lunch and Learn. Today, we're talking about Rockwell Automation MicroLogix migrations. My name is Leanne Ireland, and I'm the Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Amy Jenkins, Systems Engineer out of our Columbus, Ohio branch. Out in the comments section, ready to answer your questions, is Jim Vieira, Systems Engineer out of our Columbus, Ohio branch as well. We'll also have a Q&A portion at the end for Amy to answer in more depth. We'll get it shortly, but we'd like to allow a few minutes for attendees to join us. As you let us know where you're tuning in from in the comments. See, we already have Jim out there. He's just waiting for our questions. So that's great. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn, Rockwell Automation MicroLogix migrations. Let us know where you're joining in the comments. We'll be looking for questions as you have them in the comments while our presenter, Amy Jenkins, discusses migration options and project conversion tips for the small controller family. Our specialist, Jim, is ready to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Amy's presentation. If you'd like to reach out afterward, or if you have further questions for Amy, you can send us an email at macandmaclive@mce-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Amy. We'll have the email address on the screen for you at the end as well. Looks like we have quite a few attendees now, so let's get started. Amy, I'll pass it over to you now.
Welcome, everyone. As Leanne mentioned, my name's Amy Jenkins. I am a systems engineer at McNaughton-McKay Electric Company in Central Ohio, and I specialize in Rockwell controllers and HMIs. Today, I'm going to discuss Rockwell Automation's MicroLogix family of controllers and their migration considerations. Before we begin, let's go over the agenda. First, I will give a broad overview of Rockwell's different processor families. Next, I'll focus on what has been and what is currently offered within the MicroLogix family. I will discuss Rockwell's product lifecycle status and show the status of the MicroLogix controllers. Next, we'll look at migration options and what resources are available. And finally, I'll demonstrate how to utilize some of the migration tools. But first, let's take a look at Rockwell's processor families. Here we see a breakdown of the majority of Rockwell's controller families. The PLC5s have been discontinued for many years, along with their predecessors, the PLC2s and PLC3s, which didn't even make it on this slide. The SLC 500 family has many components that have been discontinued. Rockwell has defined clear migration options for both the SLC and the PLC5 families. Currently, Rockwell offers the MicroLogix and Micro 800 component-based families. These are known as PLCs, or Programmable Logic Controllers. These types of processors are used for small, standalone control systems. The CompactLogix and ControlLogix system-linked processors are known as PACs, or Programmable Automation Controllers. This is the newest designation for controllers, optimized to support both discrete and process applications. PACs support an open architecture and incorporate modular design. This helps multiple devices, networks, and systems communicate and operate with each other. The CompactLogix is geared for medium-sized control systems, whereas the ControlLogix family is geared toward larger systems. Now let's focus on the MicroLogix family. The MicroLogix 1000 was the first to be released in 1994, and it's displayed in the lower left-hand corner. This small and inexpensive controller opened the door for using RSLogix 500-based programs on smaller applications that previously were not cost-effective with the SLC 500 family. The catalog number for the MicroLogix 1000 starts with a 1761. It only offers embedded I/O, and it does not support any additional I/O modules. Following the MicroLogix 1000, 4 other MicroLogix processors were introduced: the 1100, the 1200, 1400, and 1500, and all of them had different catalog prefixes. All have various communication and expansion I/O module options. In this slide, they are shown in order based on increasing I/O points, functionality, and performance. This family is programmed with RSLogix 500 or RSLogix Micro software. As I mentioned, the MicroLogix was introduced in 1994, almost 30 years ago, and with that comes component obsolescence. So let's talk about Rockwell's product lifecycle status. Several years ago, Rockwell developed the product lifecycle status as a way to keep customers informed about the products they're using. Active means that the product is the most current offering in a particular category. Active mature means that the product is fully supported, but a new product or family exists. End of life means that a discontinued date for a product has been announced. Typically, a product would turn end of life within 18 to 24 months of being discontinued. This alerts customers to actively look for migration paths and/or make last-time buys. Discontinued means that new product is no longer manufactured. However, repair and/or exchange services may still be available. So how do you go about finding a product's lifecycle status? There's a number of ways. You can go to ab.com, select support, and then select lifecycle status. You will have a search field where you can enter a full or partial catalog number, and it will come back with the lifecycle status of the product or the product ranges that you selected, as shown here on this slide. Also, if you utilize Rockwell's selection and configuration tools like ProposalWorks or Integrated Architecture Builder, you will find that the lifecycle status has been incorporated into these applications. If we focus on just the smaller control PLCs, you will see that the Micro 800s and the MicroLogix 1400, as well as the MicroLogix expansion I/O, are all active. You'll notice there's no active mature PLCs. The MicroLogix 1100 has just recently been announced as end of life, joining its cousin, the MicroLogix 1200 processor, which is due to be discontinued at the end of this month. The MicroLogix 1000, the 1500, and an even smaller controller, which I hadn't mentioned before, the Pico controller, have been discontinued for some time now. So what are our MicroLogix migration options? For the most part, Rockwell would recommend going from a MicroLogix controller to a Micro 800 controller. The Micro 800 family offers 5 different versions based on communications and number of I/O points. Each Micro 800 controller offers embedded I/O. Some are offered with removable terminal blocks. The Micro 810 is a programmable relay replacer. It supports a maximum of 12 I/O points. That's 8 digital inputs and 4 digital outputs. Next in line is the Micro 820, which supports up to 36 I/O points. That includes its embedded I/O, as well as the additional 2 plug-in module capability. The Micro 830, 850, and 870 increase in I/O capability, utilizing plug-in and expansion I/O modules, as shown in the lower right-hand corner of the slide. That expansion I/O module would tie into the right-hand side of the processor. The Micro 820, 850, and 870 all support Ethernet IP communications, as well as Modbus TCP communications. The Micro 810 and the Micro 830 do not support these communications. The Micro 820 and higher models also support Modbus RTU serial communications. Part numbers for the Micro 800 controllers, as well as the plug-in modules, start with a catalog number of 2080. What are the benefits to these Micro 800 controllers? Well, they are inexpensive and they offer great flexibility with the utilization of those plug-in modules, which allow you to customize the Micro 800 controller to suit your application without increasing the footprint in the panel. Different network options are available without the need for a gateway device. Motion support is offered based on the type of Micro 800 controller that is selected. The Micro 800s are programmed with Connected Components Workbench software, or CCW for short, which is offered for free and can be downloaded right from the Rockwell website. CCW utilizes tag-based programming and supports ladder logic, function block, and structured text editors. RSLogix 500 and RSLogix Micro were register-based and only supported the ladder logic editor. Another benefit, you can reuse code utilizing user-defined function blocks that also are not available with RSLogix 500 software. CCW is a single software development environment for programming the Micro 800 controllers, the PanelView 800 HMIs, and configuring PowerFlex drives. Micro 800 tags can be directly referenced by PanelView 800 tags, which can save development time. Like the Micro 800, the PanelView 800 HMI is optimized for small automation solutions. Now let's look at each type of MicroLogix controller and look at their migration options. I mentioned the Pico controller, which has been discontinued for some time. If you happen to have one of these laying around, Rockwell recommends replacing it with a Micro 810 or a Micro 820. The MicroLogix 1100's preferred migration path is the Micro 820 or 830, and this is based on the number of I/O points. The 1100's migration path would be the Micro 820 or 850 because of the Ethernet capability as well as the number of I/O points. The MicroLogix 1200 preferred migration path is the Micro 850 or 870. For all of these MicroLogix controllers, if the application requires communication on a DH485 network, then Rockwell suggests migrating to the current MicroLogix 1400 controller. Now, the MicroLogix 1500 is a little different from all the other MicroLogix controllers. Rather than utilizing the MicroLogix expansion I/O, which have part numbers starting with a 1762, the 1500 utilizes CompactLogix I/O, which have part numbers starting with 1769. So there's several options. You can migrate to a Micro 870 if you aren't utilizing the expansion I/O, or if you just like the Micro 800 platform because of the cost. However, if you'd like to retain the CompactLogix I/O, then you would move to the CompactLogix L2 or L3 controller based on the number of I/O modules in your system. The L2 controller offers embedded I/O and supports up to 4 CompactLogix I/O modules. The L3 CompactLogix controller offers no embedded I/O and supports more than 4 I/O modules in its bank. There's a picture depicting the L3 controller in the upper right-hand corner of this slide. Another option for migration, if expansion I/O were not used, is you could move it to the active MicroLogix 1400 as well. Regarding network communications, these two gateway devices, which were used quite a bit with the MicroLogix controllers, were discontinued back in 2017. If your MicroLogix controller is utilizing the 1761 NET AIC for DH485 communications, migrate to the MicroLogix 1400 controller. Controllers utilizing the 1761 NET ENI should be migrated to one of the Micro 820, 850, or 870 controllers that offer embedded Ethernet capability, or you can migrate to the MicroLogix 1400 controller. Before I move on to migration tools and documentation, I would like to add that Rockwell issued the following statement in June of 2020. The MicroLogix 1400 controller was launched in 2008. Both MicroLogix 1400 controllers and MicroLogix expansion I/O modules, Bulletin 1762, are in active status of their product lifecycle, and we continue to manufacture and market this solution. While we cannot predict component availability and market MicroLogix products, our plan is to keep MicroLogix 1400 controller, MicroLogix expansion I/O, and RSLogix 500 software products available for sale at least until 2030. Now moving on to migration tools. Rockwell's selection and configuration tool, Integrated Architecture Builder, or IAB for short, offers a MicroLogix migration wizard. You enter the current MicroLogix part number that you are using, as well as any expansion I/O, and select a conversion option to convert the bill of material to an equivalent newer control system. Starting with RSLogix 500 and RSLogix Micro Software version 12, migration to Studio 5000 Logix Designer, which is used for CompactLogix and ControlLogix programming, is integrated into the programming software. I'll demonstrate how easy it is to convert a project. If migrating to a Micro 800 system, the recommendation is to create the project from scratch. Within CCW, there is a MicroLogix converter tool, but this is no longer supported by Rockwell. You can also copy and paste between Logix and CCW programs. I will caution you though that since RSLogix 500 is register-based and CCW is tag-based, this method is not ideal. Also, many of the instructions in both Studio 5000 and RSLogix 500 do not copy over to CCW. As far as documentation goes, Rockwell offers a MicroLogix to Micro 800 controller migration guide, as shown here. They also offer a Slick to CompactLogix application profile, which can be utilized and applied for a MicroLogix 1500 migration to CompactLogix. Last but not least, there are migration product profiles for the MicroLogix 1000, 1100, 1200, and 1500. Links to the documentation referenced in my presentation can be found in the description below. Now, let me show you some of the migration tools. First, let's go to Integrated Architecture Builder, IAB for short. If you haven't used IAB for help with your control system design, I strongly urge you to watch our virtual Lunch and Learn video regarding this. Todd Turnquist, one of our PLC product managers, does a great job demonstrating this tool. So as you can see, I already opened IAB, already created a new project. In the lower left-hand corner, there's tabs, and we are only going to focus on the hardware tab and the wizard view tab. This wizard view is what I have displayed right now. As you can see, there is a MicroLogix migration wizard. I'm going to click on this now. So first, you have to add a chassis for each MicroLogix system you want to convert and name it. I'm going to be converting a MicroLogix 1200 system. So I'm going to change the name. And then it opens my selection tool. And I am going to select the MicroLogix 1200 with micro 850/870. Next, I have to select the processor type that I want. And I'm going to select the 1762 L24BXB. This processor has 14 24-volt DC digital inputs, 5 relay outputs, and 5 24-volt DC digital outputs. As you can see, IAB populated the Micro 800 in this view. Now my 1200 supported expansion I/O, and I'm going to select an analog input and an analog output module. So I can click my 1762 IF4 and drag it over, and my 1762 OF4 and drag it over. And IAB added the necessary expansion I/O to the Micro 800 controller system. Please note over here the checkboxes. RTC stands for real-time clock. So if that was needed, I could check this box. And it added a plugin module right here. If I click the memory module, these two are combined into this one plugin. There's also a checkbox to isolate the relay outputs. And if I check that box, it adds another plugin module right here. So now I'm going to click OK. And I have one more MicroLogix processor to migrate. So I have to add another chassis. This one is going to be a 1500 migration. So here I'm going to select a MicroLogix 1500. And as you can see, I have two options to replace it with, CompactLogix or MicroLogix 1400. As I mentioned before, if you have expansion I/O with your 1500, I recommend going with the CompactLogix. So you only have to replace the processor and add an I/O card or two based on the number of I/O points utilized in the embedded I/O. A pop-up appears as soon as I do this, and here it selected a processor catalog number for me. This just so happens to be the one that I wanted to use. This offers 12 120 volt AC digital inputs and 12 relay outputs, and it's AC powered. So as you can see, I have quite a selection of CompactLogix processors to choose from. So selection of CompactLogix depends on the number of expansion I/O modules that exist and the number of I/O modules that must be added to account for the embedded I/O. If the number of modules is 4 or less, I can go with an L2 processor. If more than 4, which are the L2 processors are right here. If I have 4 or more modules, I have to go with an L3. And for my existing system, I had 3 expansion I/O modules, and I was also utilizing all of the embedded I/O. So that would make 5 modules that I need. So I'm going to pick this 1769 L30ER, which supports up to 8 local I/O modules. Going to click OK. Now, if that processor was not the one I wanted, I could have went in here and changed the catalog number, and it would have given me the pop-up to choose the CompactLogix processor that I wanted. So my MicroLogix controller had 3 expansion I/O, so I'm going to add them. So I'm going to go down here. They were actually analog. So I utilized an IF4, 4-channel analog input, and I had 2 more, but if you see, I ran out of room, ran out of slots. So I need to increase the number of slots. And then I'm going to add my 4-channel analog output. And then I had a 6-channel thermocouple card. So this is my system. Now I'm going to click OK. And I'm going to generate my hardware. And it added this entry under my MicroLogix migration wizard. And if I go to my hardware tab now, I'll see my MicroLogix 1200 and my MicroLogix 1500 migration. So for the 1200, if I click on the processor, I can see in the lower right-hand corner the catalog number. So the processor IAB chose was a 2080 LC50, that stands for Micro 850, a 24 QBB. So this controller offers 14 24-volt DC digital inputs and 10 source outputs. And also, I guess I would like to point out at this time, see the Lifecycle status. You can see it's currently active. If I click on the first plugin module, here's my memory backup real-time clock module. And then if I click on the second plugin module, you'll see my relay output card, the isolated relay output card, a 2080 OW4i. And then my expansion IO, my IF4 for my analog inputs, and then my OF4 for my analog outputs. I'm going to configure this chassis. Oh, no, I'm not going to do that right now. So let's say that I was okay. I didn't need the isolated relay outputs, and I could get away with using just the 24-volt DC outputs. I could save some real estate in the panel if I removed this relay output card and utilized the plugin modules for my analog IO instead of these expansion modules. So I'm going to show you how to adjust this system. So if I right-click on my relay output card, I can remove the module. And I can repeat the same thing for my analog modules. And when I click the configure chassis, I'm going to remove the expansion modules. I don't need any. If I go down here, find my plugin modules, I can find a 2080 IF4 plugin module. That'll take care of my analog inputs. I will caution you that the resolution is a little different between plugin and expansion, so you would want to take a look at that. As far as my analog outputs, you'll notice that I don't have a 4-channel option. I only have a 2-channel. So if I needed 4 channels, I would have to go with that expansion module like the wizard selected for me. But lucky for me, my system only utilized 2 of those 4. So I'm going to add this OF2 to my system, and I am ready to go with my MicroLogix 1200. Now let's take a look at the MicroLogix 1500. If I click on all the modules, I see my processor, the 1769L30ER. You can see that in the lower right-hand corner. I have my IA16 card, which takes care of my AC inputs from the embedded I/O. I have a 16-channel relay output module, which handles the relay outputs from my embedded I/O. And then I have my analog input module. I have my AC power supply. I have my analog output module, and I have my thermocouple card. So up here, I see errors, warnings, and information. Let's take a look at that. Here I can see an error that says there's empty slots in my chassis. I also have a couple of warnings. One of the warnings is that it's recommended that the thermocouple card be more than 2 slots away from the power supply to reduce electrical noise. And then the other warning is that IAB's Migration Wizard gives general advice on what should be chosen, and that you as a customer should do a spec-by-spec comparison to ensure that the new components will work with your existing control devices. So let me fix a couple, the one error and one of the warnings. So let's move the thermocouple card over another slot. I'm going to go ahead and move the analog cards over. So now I have all my discrete on the left and all my analog on the right. And I'm going to remove those empty slots. So I can right click on my chassis, or I can click on this configure chassis. And I'm going to remove the empty slot to the left of the power supply and the 2 empty slots to the right of the power supply. And now if you notice, my red triangle turned yellow. And now I just have the one Migration Wizard warning. So let's do the same thing with the MicroLogix 1200. If I click on that, again, I just have that Migration Wizard. I also get an information message that says this chassis requires a control power connection. And the reason for that is because this processor requires 24-volt DC as opposed to 120-volt AC like the MicroLogix 1500 was powered with. Now let's take a look at our bill of material. If I hit this project bomb icon, the $ icon, yes, I have errors, but yes, I want to see the bill of material. No, I don't need internet access. It's going to get me a bill of material, and everything's in list price. So I will get totals to each of my systems separately. So for the MicroLogix 1200 migration, it would be about $900 list price. And then the 1500 migration, it includes the existing analog modules, but you wouldn't need to purchase these items. So when you save this to Excel, you could delete those items and update your total. I also wanted to point out that it includes Rockwell software. So the connected components workbench for Micro 800 processors, this one that is here is the developer edition, which offers some enhanced features. However, you do not need this developer edition. You could just download the standard edition for free from the Rockwell website to start with. Also included is Studio 5000 Lite software, a 1-year subscription. And that's used to program the CompactLogix processor for my MicroLogix 1500 migration. And you wouldn't need to purchase this if you already own the license for Studio 5000 Logix Designer. So let's move over to an RSLogix 500 project, and I'll show you how the conversion process works. So here I have a project that is for a MicroLogix 1400 processor. As you can see, I have several subroutines. Here's my main routine. So I have some inputs that are setting an internal bit. I have my JSR instructions to jump to the other routines. If I go to my ladder 3, my outputs, I have some simple discrete logic. So my contacts, output coils, have a limit instruction. If I scroll down a little bit, I have an equal instruction and a timer instruction. So with a project, before you do the conversion, I would highly recommend that you create symbols for each input, output, each bit, each register used in your existing project. This will make a much cleaner conversion, as these will be converted over to tags in Studio 5000 Logix Designer. You can see here, all of my symbols are in green. So eStop _ OK, auto _ manual _ PVPB. Those will all be converted to tags. I would also recommend having Studio 5000 Logix Designer, the version that you need or that you want to use, already installed on your laptop, so you'll be able to open the converted project immediately. So I'm using RSLogix 500 Professional. I have version 12 installed. So to do the conversion, it's pretty simple. I go to File, Save As, and I can change my name if I want. I'm going to keep it as is. And then for Save As type, instead of an RSLogix file, I'm going to choose the Logix Designer file, the ACD. I don't need to worry about my language setting, but I do want to make sure that this box is checked. This is very important. Create alias tags in Logix for your existing SLIC symbols. I can also change the processor name here, but I'm going to leave it as is. So now I click Save. And next it will ask which type of Logix processor I want to migrate to. And I'm going to pick CompactLogix. It has the newer CompactLogix controllers included, but I'm going to pick the 1769 L30ER that I used in my IAB migration. And then I'm going to select the newest revision available to me. Click the next button, And now it wants to know how to treat the existing IO that's tied to this MicroLogix 1400. So I'm going to select update because I don't want to keep the 1762. When I select update, it shows me what was configured with the 1400. And then it also provides the recommendation for the new CompactLogix IO modules. Another important thing I want to make sure to do is uncheck this box because I don't want to place the IO modules in a remote rack with an Ethernet adapter. I want to keep these IO modules connected and local to the processor. So now I'm going to select migrate and I'm going to let it work its magic. This is nice because this pop-up gives you progress and it lets you know where it's at in the conversion. So this could take a minute or so, but here it's creating placeholders for all the embedded inputs and outputs. It's migrating the MicroLogix expansion IO to the correct CompactLogix IO modules. And it's exporting to an ACD file. And then it shows the application is migrated to Logix Designer version 31. And now this button is available to me to launch RSLogix 5000, which is the same thing as Studio 5000 Logix Designer. They changed the name starting with version 21. So I'm going to hit this button and Studio 5000 will hopefully, yep, here's the splash screen. So we'll wait for it to come up and launch the project. All right, so we have the project open. And under the controller organizer, you can see my IO configuration. Here's my IO modules. And here it created a continuous task and an event task. And if I click on the program, the routines are all under the event tasks. And how this works under the continuous task, under the main routine, it calls an event instruction to execute this first routine in my event task. Now this could be cleaned up to be much simpler. You could just get rid of, move them all to a periodic task to make it more efficient. But let's take a look at the main routine. Let me increase the size. So here you can see my symbols are now tag names. So if I go back to RSLogix 500 and I go to my main routine, here there's my man e-stop OK, my auto e-stop OK. Here's that e-stop OK at B300. So if I go to Studio 5000, here's my input bits with the tag names. And then it created placeholder bits so that all you would have to do would be replace that with the actual inputs. Here's my tag name e-stop OK. And what it did was it created a tag array of name B3. So instead of B3:00, it's now B3 bracket 0 bracket dot 0. Here's our JSRs, so all the subroutines. So it looks pretty similar. And let's look at our outputs. Zoom in. So again, like I mentioned, the bit registers are mapped to tag arrays. And if I go down, yeah, so here I have some comments on equals auto, pound limit reached. But I will point out that I've lost my comments on my input instructions. So if I go back to RSLogix 500 and I go to my outputs 2 and 3, I have my on auto, my pound limit reached. But for that particular output, I no longer have the text car drive run forward west. And it's because of those placeholder tags that were utilized. If I verify the project in Studio 5000, I get one error. And I can click on that error, it'll take me right there. And it's just alerting me that I may have to change the value that's being moved into the timer preset. since timers are handled a little differently in Logix Designer. And I'll touch on that in just a little bit. So that's how easy a conversion is. You know, you take care of the errors when you verify the project, you map the inputs and outputs. So, you know, for any MicroLogix controller, you could update it to a CompactLogix, but CompactLogix is more expensive than the Micro 800 solution. I also would like to show you what happens when we copy rungs from one software package to another. So we are going to look at the RSLogix 500, and I'm going to copy rungs 2 and 3 of this output routine. So I'm going to right click and say copy. And then I have connected components workbench opened. I created a project with a Micro 850, and I created a couple routines. So I'm going to click on this RSLogix 500 routine, and it's empty right now. And I'm going to paste. So these are the 2 rungs from RSLogix 500. And as you can see, I get no tag names. I get no descriptions. I just get the general rung structure. My limit instructions not defined. My equate instructions not defined. I do have a timer, but there's a lot of work involved to get this to be functional. Now, let me click on the Studio 5000. I have a blank rung, and I'm going to do copy the same rungs from Studio 5000 into CCW. So this one looks a little bit different. As you can see, the bit registers have been removed, and only the tag names have carried over. But they still have to be defined in the project, as you can see with this yellow triangle saying referring to undefined variable. Also, the limit and equal instructions are not defined. I do have a timer instruction. So real quick, I do want to show you how easy it is to define a tag or a variable. I can double click on the instruction, do a Control C for copy, and I just choose where I want that variable located. Local would be just to available to that routine, or global would be available to all routines. So I'm going to make it a global variable. Click OK, and now you see my exclamation point is gone. Another big difference is timers between software packages. So if I look at this timer, I can tell it's a 300 millisecond timer based on the time base and the preset. If I look at the converted project, I notice that it's been converted correctly. In Studio 5000, all presets are in milliseconds, so it's converted it accurately. If I look at CCW and I go to RSLogix 500, it actually, when I copied the rungs, it moved the base to this preset, and it moved the preset to the elapsed time. So I would have to go in and manually update this. Timers in CCW use a time data type. And so I would have to enter a T pound 300 ms for 300 milliseconds for that time data type. If I wanted a 1.5 second timer, I could change it by going T pound 1s 500 ms for 1.5 milliseconds. Another thing I'd like to mention, in CCW, jump to subroutine instructions, or JSR for short, are not required. The ladder routines will execute in the order that they are placed. So in this project, the RSLogix 500 routine would execute, and then the Studio 5000 routine would execute immediately afterward. So it's just a matter of moving the routine to the order in which you want them to execute. So there is a bit of work to do in CCW to making this a functioning project, but it is possible. So that is my demonstration of some of the migration tools. Leanne, please let me know if there's any questions that Jim answered or was unable to answer.
Hi, Amy, that was great. So there was a little discussion going on here. Tarek had asked if the Micro 800 PLC supports the DNP3 protocol as in a MicroLogix 1400 controller. And Jim answered that currently the Micro 800 does not support the DNP3 protocol. Our buddy Steve Sperry said that the DNP3 is available in partner gateways from HMS and ProSoft. And then Jim said that the ProSoft PLX51-DNPS is one of those partner gateways. So do you have anything to add? It was quite a little entertaining exchange. I think it was great. So what else can you say?
I have nothing to add on that protocol. I leave it in Jim and Steve's hands. Sounds like they had it under control.
We did share a video. We did a lunch and learn with ProSoft, and we did get that YouTube live link into the chat as well. So I think that yeah, so that was great. I don't see any other questions here, but we'll give it a minute or two because, as you know, we're in a delay. So I'm just going to wait here and see if anybody has any, and then remind everybody that if they have questions after, you know, they can always send it. We have it right there on the screen, the Mac and Mac Live at mc-mc.com.
Sounds great. Thanks everybody for listening.
So I think we're all set. Amy and Jim and Steve, thanks for being resources in the comment section. And I thank everyone for our live viewers and your time today. We hope this session was informative and engaging for you. We ask you to remember to subscribe to our YouTube channel if you haven't already for more industry content. And we look forward to seeing you again live soon. Have a great day, everyone, and enjoy.